Hey everyone, today I'm going to expand on what I was talking about with mole ratios a little bit. So, before I talked to you about how we can use mole ratios in a chemical equation and how they can be used for unit conversions. But we can actually expand on that a little bit. Let me show you what I mean. Okay? Because mole ratios are very much kind of the central piece. But we can add stuff that we've done before to the mole ratios to make them a much more useful conversion. So let's say, for instance, we had the following reaction. H2 plus O2 becomes H2O. And let's say I had something like 5.28 moles of H2. But instead of wanting to figure out how many moles of, let's say, water were produced, what if I wanted to know how many molecules of H2O are produced? So the first thing we're going to do is we're going to balance our chemical equation. List out what elements we've got. Tally them up, 2 and 2, 2 and 1. Okay, let's start by balancing oxygen. We've got 2 on the left, 1 on the right, so let's put 2 right here. That changes both hydrogen and oxygen on the right-hand side. I now have 4 hydrogens and 2 oxygens. My oxygen's balanced, but now hydrogen's not, so let's add some more to the right. Now we've got 4. We've got a nice balanced chemical equation. Okay? So we're going to start this out the same way we've been doing the other ones. I'm going to write out what I was given. 5.28 moles of H2. Now I want to figure out molecules of H2O, but I can't directly convert to it because moles of H2 is not the right substance. I have to convert it to the proper mole units first. So I'm going to copy down the moles unit that I was given into the bottom right. Now I need to switch the substance into the one I'm looking for. So I'm going to put moles of H2O on the top. Remember, if we want to switch what substance we're talking about, we have to use the mole ratio because that is the equivalence unit that we have. So using the equation, we can see that 2 moles of water are formed from 2 moles of hydrogen. Cross out our units. While we're at it, 2 over 2 is the same as 1 over 1, so we can simplify this. Because anything over itself is 1, and anything times 1 is just itself, we can just get rid of that completely. Okay, but we're in moles of H2O right now. We need to take this a step further. So I'm going to put the unit that I have left over on the bottom right. And I'm going to put the unit I want on the top, in this case, molecules, H2O. Now, I have to convert from moles to molecules. Remember, the relationship between moles and molecules is 1 mole is 6.02 times 10 to the 23rd molecules. Let's make it a little bit easier to read. Cancel out my units. Now the only unit I've got left is molecules of H2O. That's what I was asked for. So all we got to do is squish it together and solve it. On the top, I have 5.28 times 6.02 times 10 to the 23rd. On the bottom, I just have ones, so I can ignore that completely. Now, this is the point where you plug it into a calculator, okay? So you kind of have two choices here. You can either plug this whole thing into a calculator and do it that way, or you can plug this part into the calculator first. So let's go ahead and do that. 5.28 times 6.02, that is equal to 31.79. Bring over our times 10 to the 23rd. But we got to adjust this into scientific notation. Remember, the decimal point goes right after the first digit. So this is going to become 3.18. And because we moved it one spot, we have to add 1 to the decimal place. So 3.18 times 10 to the 24th molecules H2O. Here's my answer. Now we could do this with molecules or grams at the end, but what's the fun in stopping there? Let's take it another step further, okay? So let me clean up my board a little bit. Okay. Let's do something like this. Let's say I had the equation N2 plus H2 becomes NH3. Okay. And let's say I wanted to know how many grams of NH3 will be formed from 20 grams of N2, or nitrogen. So in this situation, I was given 20 grams of N2, and I'm trying to find grams of NH3. So I see that I've switched substances in this question. So I know I'm going to have to use the mole ratio. And to do that, I have to balance my equation. So let's go ahead and do that. We've got nitrogen and we've got hydrogen. We've got 2 and 2, 1 and 3. Now, conventional wisdom says that we need to balance whatever's left alone first. Last. My mistake. But both nitrogen and hydrogen have spots where they're alone. So let's try and balance NH3 first. Let's try and balance nitrogen first. Because see, if you look, there's more nitrogens on the left than the right. So I'm going to have to add to NH3 in order to balance out nitrogen. So I'm going to make this a 2. That's going to change nitrogen and hydrogen. There's now 2 nitrogens and 6 hydrogens. Now nitrogen's balanced. Let's balance hydrogen. Each hydrogen gives me 2 hydrogen atoms, and I need 6, so let's make this a 3. Now 6 hydrogens on the left, and we're all balanced. So let's put this problem together. We were given 20 grams of N2. I'm going to copy my unit down, grams of N2. And I need to use the molar mass, or not the molar mass. Well, I do need to use that, but I need to use the mole ratio because that's the only way I can switch substances. So first, I have to convert this from grams into moles. So I'm going to convert this to moles of N2. The relationship is 1 mole is equal to the molar mass in grams. The molar mass of N2 is 28.02. Let's cross out our units. Now our unit is moles of N2. Okay. Now that we're in moles, we can use the mole ratio. We're going to do that by copying our unit down, moles of N2. And on the top, we're going to put the substance that we want, moles NH3. Now is where the mole ratio comes into play. NH3 has a 2 as its coefficient, so we're going to put a 2. N2 has no coefficient, so that's just a 1. Cancel out our units. Now we're in moles of NH3. We can now make the switch into grams. So we're going to add one more step. Copy our unit down. On the top, we're going to put the unit we're looking for, grams NH3. So 1 mole is equal to the molar mass of NH3 in grams. That's 14.01 plus 3.03, which is 17.04. Cancel out our moles of NH3 unit because it's on the top and bottom. Now we squish this whole piece together into one big fraction and solve it out. So 20 times 1, we ignore that, times 2 times 17.04 over 28.02 times 1 times 1. Anything times 1 is itself, so we can just ignore that. So now we just solve this. Now remember, it didn't come up this time, but what you have to do is multiply all the top pieces together and you'll get a number. You multiply all the bottom pieces together and you get a number, and then you divide those two, okay? You have to multiply across and then divide the two numbers, okay? So let's solve this out. 20 times 2 times 17.04 equals, divided by 28.02. And our answer is 24.33 grams NH3. We just copied our unit down from here. Okay. So with these tools, you can now freely convert between grams or molecules of any substance into grams or molecules of any other substance as long as you have a chemical equation.